Hello, my name is Richard Crofts. I'm one of the directors of CS Electrical. Today I've come to Jumpin' Jack's Diner in Whitby, which is a project we successfully completed last year. I'm going to show you today how CS Electrical carry out testing on ring final circuits or socket circuits conforming to BS 7671 wiring regulations. We would carry out this test as part of the initial verification or of the periodic inspection and testing of an installation. Prior to carrying out any testing, the first thing we do is to ensure that everything is safe. We would erect barriers if necessary and warning signs indicating that testing is in progress and that live supplies may be present. Then we would check that our tester is suitable for use and is calibrated. The tester I'm using today is a Metrol MI3000. It is a 17th edition tester and it carries out all the necessary tests that we require. The next step is to prove that I've safely isolated the supply. We do that using a proving unit, which is a dedicated node supply, and a Martindale voltage indicator. The circuit I'm going to be testing is the socket circuit, which is circuit 6. So I'm going to now isolate that supply. First thing we must do is to make sure that our voltage indicator is working properly. That's where the proving unit comes in. You get your voltage indicator, insert it into the proving unit. All the lights come on, which indicates that the voltage indicator is working. We then go up to the consumer unit, test between live and earth, live and neutral, and finally neutral and earth. I now know that circuit has been safely isolated, but I still must make sure that the voltage indicator is working. So we do that by using the proving unit again. I now know it is safe to work on. The next stage of testing is what is known as the dead test. This basically means that it has been safely isolated from the supply. The next stage, we're going to test the continuity of the ring. The way that a ring main is wired is we wire a cable from the disc board round the socket outlets all the way back to the disc board again, one continuous ring. And we are testing the continuity of each leg of that ring to ensure that it is wired correctly and that there is no breaks in the system. We're going to do this test by using the low resistance ohmmeter setting on the multi-tester. But before we do that test, it's important we do a process called zeroing the leads. We do that by putting both probes together, pressing test, which shows the resistance of the leads. We then press the 0 button. Done. Zeroed the leads. It's important we do this test because we don't want the resistance of these leads included in the resistance of our circuit. The first stage of doing this testing, we put one probe on the live incoming leg and one probe on the live outgoing leg. Press test. That's registering a reading of 0.8 ohms. We repeat this process on the neutral loop, one on the incoming leg, one on the outgoing leg. Press test. Again, that's registered a reading of 0.8 ohms. Repeat this process again on the earth loop, one on the ingoing leg, one on the outgoing leg. That's registered a reading of 0.81 ohms. That's indicated to me that this circuit is wired correctly and there's no breaks in the system. If the reading was infinite, it would indicate that there is an open circuit and further investigation would be required. This circuit is wired in 2.5 singles cable, which basically means they're all the same size, and as it is a ring, they're all the same length. So these readings should be approximately the same value. If this was wired in twin and earth cable, the earth would be smaller than the live. So the reading we'll be looking for would be 1.67 times greater than the reading on the live for the earth. Once we've conducted this test, we will document our results on the test sheet and then we'll input it onto the computer at a later date. For the next test, we take the incoming live and we connect it to the outgoing neutral using a connector block. We then take the incoming neutral and connect it to the outgoing live. This is basically opposites. This will form what is known as a figure of 8 configuration. It is the longest loop possible in the ring. We then go to each socket outlet and take a resistance reading between the neutral and the live. We go to each outlet on the circuit and we test between live and neutral. All the readings on every outlet should be more or less the same. If they wasn't the same, it would indicate that we've got the wrong pairing back at the disc board, or that there is a radial spur in the circuit. The reading is showing 0.47 ohms. These readings should be roughly a quarter of the line and the neutral loop added together. For the next stage, we repeat the process. But this time, instead of using the neutrals, we swap the neutrals with the earths. So we have got, in the connector block, the incoming live to the outgoing earth, the incoming earth connected to the outgoing live. Again, this will form the longest possible loop in the system, which is called a figure of 8. The next process is we go to every socket outlet again, and this time we test between live and earth and register the readings. We now go to each socket outlet again and repeat the process between earth and live. That's showing 0.46 ohms. Same as before, if these readings were not more or less the same at each outlet, it would indicate that the wrong pairing is back at the disc board, or that again there's a spur in the circuit. And same as before, these readings should be approximately 1/4 of now the live and the earth loop added together. By conducting this test, we have now confirmed that polarity is correct on the circuit. The next stage of testing is to carry out the insulation resistance test on the circuit. We set the multimeter to the insulation resistance setting, and that induces 500 volts DC down the circuit. It's imperative before doing this test that all voltage sensitive equipment is disconnected from the supply. We put the earths back into the connector, and we do this. First, connect one probe to the lives, one probe to the neutrals. And we're testing. This test is inducing the voltage down the conductors, proving that the insulation is of good quality and sound, and there's no short circuits in the system. That's indicated 1000 megohms. We now move from the neutral to the earth. We are testing between live and earth. Again, that's indicated over 1000 megohms. We now move from the lives to the neutrals. So we're testing between neutral and earth. Again, that's indicated over 1000 megohms. So that circuit has passed. BS 7671 wiring regulations states for this circuit a minimum pass of 1 megohms. I now know that this circuit is safe to turn on and supply before we conduct the next set of tests, which are known as the live tests. With the cables now safely connected back in the consumer unit, the next stage of testing is what is known as the live tests, which basically means that the supply is turned back on. Using what is called an earth fault loop impedance tester setting on the multi-tester, we go around every socket outlet measuring the maximum ZS recorded. As there is an RCD supplying the whole installation rated at 30 milliamps, it's important that we put the RCD setting on the multi-tester. Otherwise, whenever we plug into a socket to conduct a test, it will trip out that RCD and no reading will be recorded. BS 7671 wiring regulation states that for a MCB 32 amp type B breaker, a maximum value of ZS should be no more than 1.44 ohms. I now need to go around every socket outlet, taking a measurement, ensuring that they are more or less all the same and they are not greater than 1.44 ohms. That is how we at CS Electrical would carry out testing on ring final circuits. This is just one of the tests we would do when we test an installation. There is numerous other tests we would have to do when we complete the test of a full installation. Please note that only a fully qualified, competent electrician or a reputable firm should ever carry out these tests. Thank you for taking the time to watch this video.